NASA scientists watched in horror as astronauts began making deadly mistakes. They traced it all back to one thing you're probably doing wrong every single night. After spending over $100 million and decades of research, they cracked the sleep code that the wellness industry doesn't want you to know. Forget everything you've ever heard about getting 8 hours of sleep. NASA discovered that the timing of your sleep is far more important than the duration, and one simple adjustment can make you wake up feeling like you slept for 12 hours, even when you only got 6. By the end of this video, you will have the exact sleep strategies that keep astronauts sharp and focused during life-or-death missions in space. It all started in the early days of the space program. NASA was facing an invisible, deadly enemy. Astronauts, the best of the best, were making critical errors. Their reaction times were slowing down. Mission controllers watched with growing alarm. During long flights, the human brain was failing in space. Now, these weren't ordinary people. They were handpicked from tens of thousands of applicants, all with perfect physical health and exceptional minds. Yet something was causing them to make these dangerous, potentially fatal mistakes. The problem wasn't the multi-million-dollar technology or their world-class training. It was something far more fundamental. Something we all do every night. These elite pilots were suffering from severe sleep disruption, and in the unforgiving vacuum of space, a single mistake caused by fatigue could mean instant death. This crisis forced NASA to commission the most comprehensive sleep studies ever conducted, and what they discovered completely shocked the scientific community. One study, published in the prestigious Journal of Sleep Research, found that after just 24 hours without sleep, a person's cognitive performance drops to the equivalent of being legally drunk. But here's the truly disturbing part. After sleeping just 4 hours a night for 2 weeks, your brain functions as poorly as if you hadn't slept for 3 days straight. And the worst part of all, you don't even realize how impaired you are. Your brain tricks you into thinking it has adapted. You feel normal, but objective measurements show dramatic declines in your reaction time, your decision-making abilities, and your memory. This means millions of people are walking around every day significantly impaired without even knowing it. This terrifying realization led to the creation of NASA's Fatigue Countermeasures program at the Ames Research Center in California. This program became the undisputed gold standard for sleep research worldwide. For over 3 decades, it has generated more than 500 peer-reviewed scientific publications, developing precise science-backed interventions for optimal sleep. Today, you're going to learn their most powerful, life-changing findings. NASA's single most important discovery centers on something called the circadian rhythm. This is your body's internal 24-hour clock that controls virtually every biological process you have. On Earth, this clock is synchronized by the natural cycle of light and darkness. But on the International Space Station, astronauts experience 16 sunrises and 16 sunsets every single day. That's a new sunrise every 90 minutes. This completely throws their circadian rhythm into chaos. NASA researchers found that this dysynchronization wreaks havoc on hormone production, immune function, cognitive performance, emotional regulation, and even cellular repair. When your internal clock is off, your entire body suffers. So why does this matter to you here on Earth? Because modern life has unintentionally created similar conditions. Think about your typical evening. The sun sets, but instead of natural darkness, you're bathed in artificial light from your phone, your TV, and the LED bulbs in your home. Your brain is getting a constant signal that it's still daytime, even at 11 o'clock at night. Central to this whole problem is melatonin, your body's primary sleep hormone. Groundbreaking NASA studies, published in the Proceedings of the National Academy of Sciences, revealed that melatonin production is extremely sensitive to blue light, specifically light with wavelengths between 460 and 480 nanometers. This is the exact type of light that beams out from your phone, your computer, and modern LED bulbs. When astronauts were exposed to the standard lighting on the space station, their melatonin production was suppressed by up to 80%. This single fact explains why so many people struggle to fall asleep at night. You are constantly surrounded by light that is actively preventing your brain from producing the very hormone it needs to initiate sleep. NASA's brilliant solution was an $11.2 million LED system called the Solid-State Lighting Assembly, installed in 2016. This system dynamically adjusts the light throughout the day to simulate natural conditions on Earth. In the morning, astronauts get intense, blue-enriched light to promote wake. Then, in the evening, the system shifts to a warm, amber light with minimal blue wavelengths, signaling to their brains that it's time to wind down. The results were astounding. Studies showed astronauts using this system experienced significantly improved sleep quality, fell asleep faster, and had better daytime alertness. And this same principle can transform your sleep at home, starting tonight. But NASA didn't stop there. They made another crucial discovery about the 90-minute sleep cycle. Every night, your brain cycles through 4 distinct stages. Stages 1 and 2 are lighter sleep, where you process memories. Stages 3 and 4 are the deep, restorative sleep where physical repair occurs. Finally, you enter REM sleep, where most dreaming happens. One complete cycle takes about 90 minutes. Here's a secret most people don't understand. Waking up at the wrong point in the cycle can leave you feeling more exhausted than if you had slept less. This is called sleep inertia, and it can impair your cognitive function for up to 4 hours after waking. NASA's research found that waking up during deep sleep caused reaction times to be 50% slower than waking up during light sleep. The solution is incredibly simple. Time your sleep in 90-minute increments. If you need to wake up at 6:30 in the morning, going to sleep at 11 p.m. gives you 7.5 hours, which is exactly 5 complete sleep cycles. Or going to sleep at 12:30 gives you 6 hours, or 4 complete cycles. Either of these options will leave you feeling far more refreshed than sleeping for 7 hours, which would force you to wake up in the middle of a deep sleep cycle. NASA also discovered the power of sleep banking. They found that astronauts who extended their sleep to 9 or 10 hours for several nights before a demanding mission performed significantly better under pressure. You can use this exact strategy before a big job interview, an important exam, or a major presentation. One of NASA's most famous findings came from their research on napping. In a landmark 1995 study on airline pilots, they found that a planned nap averaging just 26 minutes resulted in a 34% improvement in performance and a 54% improvement in alertness. This study literally changed airline policies worldwide. The ideal NASA nap is between 10 and 26 minutes. It's just long enough to restore alertness, but short enough to avoid falling into deep sleep and waking up groggy. The best time for this power nap is between 1 and 3 in the afternoon, when your circadian rhythm creates a natural dip in alertness. A brief nap during this window can restore your afternoon performance back to morning levels. They even validated the caffeine nap. It sounds strange, but it works. You drink a cup of coffee quickly, then immediately lie down for a 20-minute nap. Since caffeine takes about 20 to 30 minutes to kick in, you wake up just as the stimulant hits your brain. Studies confirm that a caffeine nap is more effective than either caffeine or a nap alone. NASA's environmental research also gave us critical insights. They established that the optimal temperature for sleep is between 65 and 68 degrees Fahrenheit, or about 18 to 20 degrees Celsius. As you fall asleep, your body's core temperature needs to drop slightly. A warm room prevents this natural process and can disrupt sleep. And what about noise? The space station is surprisingly noisy, around 65 decibels. But NASA found that consistent background noise, like white noise, can actually improve sleep by masking sudden, disruptive sounds. The key is that a sudden change in volume is what wakes you up, not the steady noise itself. A simple fan or a white noise machine can work wonders. Perhaps NASA's most emphatic recommendation is about darkness. Complete and total darkness. Even a tiny amount of light can suppress melatonin and disrupt your sleep. One study found that having a light on in the room before bedtime suppressed melatonin by more than 50%. Even light shining through your closed eyelids during sleep can increase insulin resistance the next day. The prescription is simple. Use blackout curtains. Cover the tiny LED indicator lights on your electronics, and use a quality sleep mask if you have to. So let's put all this incredible science into a simple protocol you can start using tonight. 3 hours before bed, start reducing your blue light exposure. Dim the lights in your house, switch to warm-tone bulbs, and put all your screens in night mode or wear blue-blocking glasses. 2 hours before bed, stop eating large meals. Digestion raises your body temperature, which interferes with the cooling process needed for sleep. Also, avoid alcohol, which might make you feel sleepy initially, but severely disrupts your sleep later in the night. 1 hour before bed, lower your room temperature to that cool 65 to 68 degrees. Begin your wind-down routine. This could be light stretching, reading a physical book, or meditation. Absolutely no stressful content or work emails. In the final 30 minutes, focus on transitioning your nervous system into rest mode. Practice slow, deep breathing. A simple technique is inhaling for 4 counts and exhaling for 8 counts. This activates your body's relaxation response. Make sure your room is cool, dark, and quiet, and put your phone in another room. NASA studies showed that even having your phone visible can delay sleep. Then, calculate your wake-up time based on those 90-minute cycles. Set your alarm, and then do not look at the clock again. Clock watching only increases anxiety. Your morning routine is just as important. Within 30 minutes of waking up, get bright light exposure, step outside for at least 10 minutes. This blast of morning light anchors your circadian rhythm for the entire day and dramatically improves your sleep the following night. And finally, delay your first cup of coffee for 60 to 90 minutes after you wake up. Research shows that immediate caffeine interferes with your body's natural wake-up hormone, cortisol, which can lead to that dreaded afternoon crash. The science is clear. Poor sleep impacts every aspect of your life. NASA spent decades and hundreds of millions of dollars figuring this out for their astronauts. Now, you have their playbook. Start with the highest impact changes. Control your evening light, cool down your bedroom, and time your sleep in 90-minute cycles. These aren't just wellness trends. They are proven interventions backed by some of the most rigorous science on the planet. If this video helped you, please share it with someone you know who struggles with sleep. Subscribe for more science-backed strategies to improve your life. Let me know in the comments which NASA strategy you're going to try tonight. Sleep isn't a luxury. It's the very foundation of human performance. NASA proved it. Now, it's your turn.